record. There we are.
Okay.
So the lab is called Derivatives of Polynomials Lab. So let's start. I'm sure that you all got this. What is the slope and the derivative of the function?
Did you get 0 for?
Yeah, I got 0.
Same here.
Like
Zero?
all of part 1 is 0.
Yes, of course. 0.
And then for the conclusion part, the derivative equals 0. I put that.
I put in that for whatever constant function f of x equals c, the derivative of f of x is the slope of the original f of x. Right?
The
I
slope
don't know.
of the
That might be a
original-
bad way to word it. I just put 0 literally for everything on
Yeah, that's what I
part
did.
1. Because if you say it's the same as the original, then if it has like exponents and all that, it won't be true.
Correct.
I just think of it like if f of like kind of like what he was saying, if f of x equals 2 and you find the derivative of 2, it's just going to equal 0 since there's no like x with it. If
Well,
it
in
was
this-
2x, then it would be 2, but
I mean,
there's no variable with it.
in this case, it does go to that. It does equal the slope of f of x. Okay, let's go to part 2. What is the slope of tangent line of f? Number 1.
For 1, I got 2. 2, I got -1. And then 3, I got 3.
Makes sense.
Yeah, that's what I got.
Same here.
Same for the derivative part.
The same thing. Oh, we go at the same answers. Wonderful.
Yeah.
Let's go
And
to
then-
part
Oh.
3. Do we get 3x squared for number 1?
Back.
Yeah,
Yeah.
3x squared.
Yep.
For the second one, 4x cubed.
Yeah.
Yep.
Number 3, 5x to the 4th power.
Yeah.
Yes.
And here we begin to have our theorem.
So wait. So it's basically sorry. So basically, like to find the limit definition, you have to like take whatever exponent it is,
Mhm.
and you put it in front of the variable,
Yes.
and then like for the exponent, you'll just reduce it by 1.
Yes.
Yeah.
See,
Okay.
but I was a little confused by that because isn't the limit definition technically the like a plus h? And then power rule is what Harald just described?
I think so.
I wasn't completely sure. Because yeah.
Well, I think it's different here. Here it's the power rule with the derivative. And
I think the actually I remember seeing this in the book, the power rule. It's basically just a summary of the entire process because they show that A and H formula, and it's just like
Yeah.
half a page long. So
Right.
the power rule was just like a summary of it.
Okay. I just thought, yeah, the limit definition and power rule were different.
I think they should be the same.
yeah.
Okay, cool. I didn't write it out, thankfully, but
Yeah.
So let's go to part 4. For number 1, did we get 6x?
Yeah.
Let me check. Yes.
Number 2, 12x squared.
Yeah.
Yes.
Yeah.
For number 3, 8x cubed.
Correct.
And for the power rule, for the theorem, it's essentially c times n times x to the n minus 1.
Yeah, that's what I got.
Yes.
Now for
Part
part 5.
5.
And here it begins to get a little more complicated.
Yeah.
For number 1, did we get f of x equals 35x to the 6th power minus 12?
Yeah.
Yes.
Number 2, did we get negative 84 times x to the 11th plus 81x to the 8th plus 12x squared?
Yeah.
Yes.
For number 3, that's a long one,
Yeah.
so brace yourselves. Negative 81x to the 80th power plus 75x to the 74th power minus 53x to the 52nd power minus 43x to the 42nd power plus 27x to the 26th power plus 16x to the 15th power minus 3x squared.
Yeah.
Correcto.
Yes.
For number 4, 2.4x to the 1.4 power.
Yeah. That's what I got.
Wait, I'm sorry, repeat that. 2.4x to 1.4? Oh
Yeah.
yeah, because you reduced it. My bad.
2.4 minus 1 is 1.4.
Yeah. I overlooked that one.
Number 5, 7x to the 4th power minus 5x.
Yes.
Yeah.
Now we'll come to the Desmos graphing section. I was a little confused on that part.
Um.
Well,
Okay.
yeah,
Yeah. I mean, when I plugged it in, they were both the same line, so I just put for number 1 that they're exactly the same.
Yeah. They should
Which-
be identical.
Yeah, to me would
Yeah,
make
it's
sense
true.
because the derivative of e to the power of x is e to the power of x. It's the same thing.
For number 3, we're supposed to prove or disprove a hypothesis concerning the derivative of f of x equals e to the x.
I wrote that since the derivative of a to the power of x, sorry, I had a timer going off. The derivative of a to the power of x equals a to the power of x ln in parentheses a. Is there a way to share my screen?
Yeah.
There should be a button for it.
It's the green
well.
button in the
Oh, I
middle
can't.
on the bottom, yeah.
Screen. Share. It's a little weird, but
Oh
know.
yeah, look at that.
Nice.
Oh, Kami. I love that app.
yeah, me too. Because I like doing everything online if I can.
Yeah, I used to use it a lot before I had my iPad.
I want one so bad that I can like write on with the little
Get yourself
pen.
like a refurbished one for like $100 or something.
100?
Yeah, no, there's like a model, it's like the most basic iPad model, and like they sell it for like really cheap. But I mean it did okay, I'm sorry, let's just get back to the lab. Sorry about that.
No, it's okay. I was wondering anyway. So. Did you guys get this?
Yeah.
Cool. And then I guess we could just look at these. Did you guys get this?
Yeah.
So
What is ln? Okay, I have to ask this. What
it's
is
the natural
Log.
log.
it's what exactly?
It's called natural log. It's I don't
Oh,
know how
it's
to
natural, and then
describe
E is
it.
like base 10. Wait,
Oh.
no, I'm sorry, I mixed that up. Log is base 10.
It
Yeah,
almost acts like a log.
100.
It's a different way to. I think it's like almost the inverted version of a log. It's
Yeah.
something related to it.
I'd say if you're not 100% sure, look it up because it is confusing, but I just
Yeah.
memorized it from
E and
calculus.
LN, I think, are the like. I'm pretty sure they are the same thing. It's Just the difference between that and log.
Yeah, and then one of them's like the integral of the other, I think. I don't know, but we're not that far in yet. You guys got this, right?
Yeah.
Yeah, yeah.
And then this is what I got for one.
Correct.
Yeah,
Points.
that's what I got.
This is what I got for two.
Yeah.
Yay. Okay. I'll stop sharing.
Alrighty. Let me pull up the problem
prompts.
questions real quick.
Okay, 1 second.
So it's the same questions.
Yeah. The same
Yeah,
thing.
it's like what's hard, what's easy, and then
Yeah.
what do you have
like,
questions
what-
about? So
All right. Yeah. So all right. Kirill, you want to go first?
Thank you. What was the hardest or most unclear learning objective from this lab?
for me, I was fine with everything other than I wasn't sure whether power rule and limit definition were the same.
For me, the natural log law was most challenging to understand. ln. About E. I'm still not very sure about what they do exactly.
That's fair.
Yeah, I'd say definitely look that up because it is really confusing.
We're getting a chemistry tutor. He'll set you straight.
I think
Uh,
the hardest thing for me was I kind of tripped myself up on the tangent line thing, so it just took a little longer. But like it was just because I was thinking of something else.
yeah. I'd say the hardest part was part 7 for me. Yeah, having because I mean I knew like I knew to use point slope and all that, but it was just like x to the exponent of 2/3. I didn't know how to play that into the equation. So yeah. Okay, and so what was the easiest part of the lab for you guys?
For me, it was like part 5 and majority of it just finding using power rule to find the derivative.
Same goes for me. I found it very straightforward where you had to reduce each time you got the derivative, you reduce the exponent by 1.
Yeah, the power rule is pretty easy to grasp.
It's
Yeah,
straightforward.
same here.
Third prompt. What do you wonder about the lab concept still?
I wonder how we're gonna play in uh like using the power rule and then getting the results from that and like what we're gonna use with those results, I guess. And like how we're gonna like put them into other equations and stuff. Uh that's it really.
I kind of wish it gave us like, because I don't know how we would use the power rule in real life. You know what I mean? Like real life scenarios.
Engineering, for example?
Yeah. But like I want to like understand how it would be used.
Fair enough.
Yeah,
That is a good point.
honestly, probably not in too many occasions, but I don't
I guess
really.
it's good for I guess learning about it is just good, I guess, for developing problem solving skills, maybe. I don't
Yeah,
know.
Yeah,
Of
that's
course.
true.
But yeah, I don't even think like in engineering you'll be applying the power rule to that many things. So yeah.
right. And yeah, I don't really have any other
Yeah.
questions other than that one I asked you guys.
So,
Yeah.
does that wrap everything up? Is this...
It should be it.
Yeah.
Then I will stop the recording.
Perfect.